Hello everyone, in this video we are going to talk about trigonometric identities. In the diagram there is a unit circle and the point P is on this circle. Well, the equation of this unit circle is x squared plus y squared equals to 1. Hope you remember that in general the equation of the circle is x minus a squared plus y minus b squared equals to r squared, where AB is the center and r is the radius. So for the unit circle, we have the equation x squared plus y squared equals to 1. And we recall that cosine theta in the unit circle, that's equals to the x coordinate of P, which equals to x, and sine theta equals to y, tangent theta equals to y over x. Then we can substitute cosine theta equals to x and sine theta equals to y into the equation of the unit circle. What we can have cosine squared plus sine squared equals to 1. And also we can substitute cosine theta equals to x and sine theta equals to y into the formula of the tangent. We can have tangent theta equals to sine theta over cosine theta. Here are the two trigonometric identities we learned from this lesson. And now we use these two identities to simplify trigonometrical expression and also to do some proof of that. Now let's see some example question. So question 1, simplify the following expressions. For part A, we have 3 times sine squared 2 theta plus 3 times cosine squared 2 theta. That equals to, we can take out the common factor, that is 3. So 3 times sine squared 2 theta plus cosine squared 2 theta. So sine squared plus cosine squared equals to 1. Here it equals to 1. We can write down that equals to 3 times 1 equals to 3. Now for part B, the square root of 1 minus cosine squared 2 theta over cosine 2 theta equals to that we know that sine squared theta plus cosine squared theta equals to 1. We can also written as that 1 minus cosine squared theta equals to sine squared theta. Or we can write down that 1 minus sine squared theta equals to cosine squared theta. So in here we can write down that the square root of 1 minus cosine squared 2 theta equals to the square root of sine squared 2 theta. And then over cosine 2 theta. So we have sine 2 theta over cosine 2 theta. That equals to tangent 2 theta. Now for part C, we have cosine to the power of 4 plus cosine squared times sine squared. We can take out the common factor, that is cosine squared theta. And bracket times cosine squared theta plus sine squared theta. We know that cosine squared plus sine squared equals to 1. So we write down that equals to cosine squared theta times 1 equals to cosine squared theta. Right? Now let's see question 2. So prove that cosine to the power 4 minus sine to the power 4 over cosine squared equals to 1 minus tangent squared. Now let us start from the left-hand side. So left-hand side equals to cosine to the power 4 minus sine to the power 4 over cosine squared. So look at the denominator, we can written as cosine squared theta plus sine squared theta times cosine squared theta minus sine squared theta, which we use that x squared minus y squared equals to x plus y times x minus 1. And the denominator is still cosine squared theta. In here, we found that cosine squared theta plus sine squared theta equals to 1. Now we can write down that equals to 1 times cosine squared theta minus sine squared theta over cosine squared theta equals to cosine squared theta minus sine squared theta over cosine squared theta. That equals to cosine squared theta over cosine squared theta minus sine squared theta over cosine squared theta. And cosine squared over cosine squared, that is 1. Then minus, so sine squared theta over cosine squared theta, we can write down that sine theta over cosine theta and the square of that, which equals to 1 minus tangent squared theta. And that equals to the right-hand side. So we have proved that. Now let's move on to see another example. To prove that tangent theta plus 1 over tangent theta equals to 1 over sine theta cosine theta. So start from the left-hand side. That equals to tangent theta plus 1 over tangent theta. Since tangent theta equals to sine theta over cosine theta, we can write down that, and plus 1 over tangent theta, which means 1 over sine theta over cosine theta, equals to sine theta over cosine theta plus cosine theta over sine theta. Now we try to add these two together. We have sine theta cosine theta in the denominator, and in the numerator we have that sine squared theta plus cosine squared theta. That equals to 1 over sine theta cosine theta. That equals to the right-hand side. So we done the proof. Now let's move on to see the third question. We have that given that cosine theta equals to minus 4 over 5 and that theta is a reflex, find the value of sine theta and tangent theta. So we know that since we have the trigonometry identity that sine squared theta plus cosine squared theta equals to 1, we have that sine squared theta equals to 1 minus cosine squared theta. That equals to 1 minus 4 over 5 squared equals to 1 minus 16 over 25 equals to 9 over 25. So we have two values of sine theta. That is sine theta equals to plus minus 3 over 5. Well, the question said that theta is a reflex, which means theta is in the third and the fourth quadrant. And let us see the cast diagram. CAST. So in the third and in the fourth quadrant. From the question, we know that cosine theta equals to minus 4 over 5. So cosine theta equals to minus 4 over 5, that is negative. So it is impossible theta in the fourth quadrant. Since in the fourth quadrant, the value of the cosine theta should be positive. So the only possible value is that theta is in the third quadrant. And in the third quadrant, the value of sine theta is negative. Thus, we can get that sine theta equals to minus 3 over 5. That is the value of the sine theta. We also need to find the tangent theta. We know that trigonometry identity that tangent theta equals to sine theta over cosine theta. That equals to minus 3 over 5 over minus 4 over 5 equals to 3 over 5 times 5 over 4 equals to 3 over 4. So, we've done the part A question. Now let us see part B. Given that sine alpha equals to 3 over 5 and that alpha is obtuse, find the exact value of cosine alpha and tangent alpha. So firstly, let us find the cosine alpha. We know that sine squared alpha plus cosine squared alpha equals to 1. So cosine squared alpha equals to 1 minus sine squared alpha. That equals to 1 minus 3 over 5 squared equals to 16 over 25. We can have that cosine alpha equals to plus minus 4 over 5. Now the question said that alpha is obtuse, which means alpha is in the second quadrant. Now let us see the cast diagram. We have CAST, and in the second quadrant, we have that the value of the cosine alpha should be negative. So we have that cosine alpha equals to negative 4/5. We know the value of sine alpha and cosine alpha, so we can find the value of the tangent. Tangent alpha equals to sine alpha over cosine alpha. That equals to 3/5 over minus 4/5. That equals to 3/5 times negative 5/4. So we have negative 3/4. So we've done this question. So what we have learned in this lesson is that we need to use these two trigonometric identities to simplify some expressions and to do some proof. So you need to remember these two identities. Okay, here is the end of the lesson. Thank you for watching.